Um, sorry about that. So something that I'm getting to is the fact that I will be recording lectures and posting videos on YouTube so that you can go back and rewatch. Okay, so but the note about the grades is just ignore anything that says overall. Don't worry about that because I'll go back and drop whatever I need to drop, scale whatever I need to scale, and get your grades that way. We will be using a program called Graphing Calculator in this class. That's an unfortunate name because it is not the handheld TI-83 that you are probably used to. It's an actual computer program that does everything that your TI does and more, better, faster, more beautifully. Okay, so we're going to be using that, and I'm going to be getting, hopefully today, the access information for you guys to get that onto your computers. We will be using it in class, so if you have a laptop, you're probably going to want to install it on your laptop. But like I said, directions for how to get that onto your machine are forthcoming. I'll have them on Blackboard as soon as I get the information. About halfway through the semester, we are going to start using my math lab for some of your homework assignments. Again, that information also forthcoming, but if you're curious about like whether or not you need to buy a textbook and things of that nature, my math lab has the textbook in it. So when you buy the access code, you automatically get an online version of the textbook. If you want the paper copy, I think it costs like $10 more. It will be what you use for Calc 2 and 3 as well, so it is an investment to keep that in mind. I will be providing a lot of the materials directly to you through Blackboard. And you'll notice that some of the language is a little bit different. So every once in a while, I'll try to make references to, here's what we've been talking about, here's how it relates to your traditional textbook that you have on your computer. But just be aware that some of the language will be a little different throughout the semester. Okay. Are there any questions so far? Yes.
I know we got a physical math book for this class. Is that the same as going to be on math lab?
Yes.
So if you have that, do you need the access code in my math lab?
You still need the access code because the online homework assignments are going to be on my math lab.
Will the access code be a part of the package you bought?
It should be. Mm-hmm. Yeah. And if it's not, then you should go get your money back. Okay. Other questions? No? Okay, so let me just quickly show you. On Blackboard, can you see? Gosh, it looks really small. I don't know how to change that. Anybody know how to change that? View? Zoom? Zoom in? Aha. Okay, so when you're in here, you'll see, just the course homepage is where all the announcements are. So you can already see I've posted something for you guys to do, namely read the syllabus. Once these directions come up, you're going to install Graphing Calculator, and then you're going to complete your first homework assignment because that's already up. And so you'll find that under assignments. And you'll see I've got a PDF here for you to download. Please follow the directions. There are more than 5 pages in here. I only want you to do pages 1 through 5. Okay. And as far as completing the assignment, I've written it here, but just to reiterate, you're going to be reading and writing for me, right? This is not going to be the kind of class where you just produce an answer and you wash your hands of it and you're done. So as far as how much you're going to write, try to be succinct, right? Clarity, and like not filling a novel is a very good skill to have. So I want you to be succinct. I want you to turn in professional work. I'm going to have, Marissa Bell, are you here? Great. So your grader is going to be grading based off of professionalism. How does it look, right? Because at least from my experience, if it looks like you've put some time and energy into organizing your thoughts, chances are you actually did, and good things will happen in your brain. Yes? Handwritten is fine. Okay. If you want to type it, you can. But handwritten is fine. Other questions so far? No, that's fine.
I don't want to know what heading, written word, heading.
I'm gonna have you fold it hot dog style, write your name on the outside. I'll walk you through it. Okay. On Wednesday when you turn it in. Okay. Well, since I've already mentioned her name, Marissa, would you like to introduce yourself?
My name is Marcela Rodriguez. I'm going to be your grader, and I'm going to guide you to the reservation on Mondays and Wednesdays. What else? I'm a PhD student. This is my first year in applied mathematics, and I'm going to be here with you all. And also, I'm going to be having tutoring hours that I will tell you later, maybe the following week, when and what time.
And where?
Where, yeah. I don't know yet.
Okay. And let's see. So if you were here before class, you saw a gentleman helping me set up. This technology thing is brand new to me. I'm still getting used to it. His name is Mark Ashbrook. He's fantastic. He's taught this course the last, I think, 3 semesters in the version that you will be receiving. So he is by far the expert, and he has extremely generously offered his time and support for you. So his office hours are Tuesdays and Thursdays, 11:30 to 1 in ECA 209. So please take advantage of that. My office hours are on Blackboard, but just to reiterate, ECA 383, Mondays and Wednesdays after class, and then Tuesdays from 10 to 11. So between myself, Marissa Bell, and Mark, these are the people that you want to be seeking help from. On my math lab, there's an online version. Yes.
Will we bring like a hard copy of any textbooks?
No. There will occasionally be assignments that I'll have you print out and bring, but so you should have access to a printer for this class. But no, you don't need to bring in a textbook. It's online. Yes. I'm not sure if it's compatible with tablets, but we can figure that out. Do you have a desktop at home? Okay, so worst case scenario, we'll have you partner up with somebody in class. Okay. Any other questions so far? No? Okay. All righty. Now seems like a good moment to pause and take attendance, because I have to do that. There's a lot of you. So we're going to make this go as fast as possible. Okay. Anthony. Kaiser. Rudger. Adam. Jan. Ankita. Elena. Yumang. Tyler. Bethany. Teddy. Payun. George. Taylor. Annabelle. Moises. Danielle. Daniel. Yeah? Sorry. Jessica. Kyle. Sarah. Taylor. Alexis. McLean? How do you say it? McLean. Sorry. Nervous, remember? Okay. Matthew. Lauren. Penny. Taylor. Scott. Ryan. David. Horacio. Horacio. Ha. Frank. Help me out. Adidas? Like the shoe? Sweet. Okay. Shelly. Allie, or no. Help. Eiley. David. Was that a here? Justin. Anna Lena. Did I do that right? Anna? Nathan? Nathan? Jonathan? Darren? Ruby? Taylor? Philip? Miranda? Renee? Dakota? Riche? Jessica? Madeline? Ashley? Joseph? Caesar? Harrison? Naeli? Naeli. Ah, cool. Courtney. How do I say it? Jafu? Maxwell. Katya? Christopher. Haha. There are a lot of you guys. Okay. My goodness. All right. That was exciting. I don't know how we're going to do that every day. That takes a while. Okay. As promised, this class will be different. Okay? So let me give you a little bit of motivation for why, because I think it's important, right? At a university, you guys are here to broaden your minds, to learn, right? To think critically. These are valuable skills. So if somebody comes to you and says, I want to do something different, you should probably ask why, right? So what I'm going to give you a little bit of today is some background about math education in the US compared to other countries. And then we're going to talk briefly about what calculus is and how we're going to develop it. So, all right, so a couple years back, and by a couple, I mean a lot, there was a study done called the TIMS, where they went around and they recorded a bunch of classrooms in Japan. I'm jumping ahead of myself. Pause and rewind. Okay, first, let's talk about, I don't even know why. I looked at it and then I skipped ahead. So natural science and engineering degrees. Per 100, 24-year-olds. When you look at this data, this is from 1975. Where's the US? Towards the bottom. We're here, right? In 1975, we were doing pretty good. About third in the country, or in the world, right? For a number of science and engineering degrees. So you go to a dinner party, you walk around, you're like, yeah, I know you people, okay? And you can compete. How do you think we compare today? So, not surprisingly, these are put in order by today, right? So, what is this? Does this mean something to you guys? What does that mean? Implications? Uh-huh.
It means that overall there's been a steady growth in the effort that countries have come on and then what they continue to have their students graduate with science and engineering degrees, whereas in some other countries like Germany and the United States, it's been very slow progression
Yeah.
of people graduating with those degrees.
Right. So you probably hear a lot. Oh, do you have something to say? You probably hear a lot in like government politics. I'm talking about like the push for STEM education, and we're falling behind, right? Other countries are pushing ahead, and technology is advancing. And what do we have to offer, right? It's a global market now, so you guys are competing with people on a global scale. So this kind of trend is not really what we want. I have a hunch, humble little me, right? But a lot of that has to do with the social stigma that we have against mathematics, right? It's, when did this happen? When did it become okay for people to be like, I suck at math? And that's acceptable, right? Like you can go somewhere and say that and nobody looks at you funny. But if you were to walk into a room and say, I suck at reading, then people are going to look at you weird. How did that happen? And that's a rhetorical question. I don't know. You might have an answer. I can't figure it out. I don't think that's okay. I don't think anybody should feel that way about mathematics, in particular because it's a way of thinking. It is one of the most powerful tools that you can develop for your brain. All right. So this is the study that I was jumping ahead to. The TIMS video study videotaped 100 randomly selected 8th grade classrooms in each of Germany, Japan, and the US. And then what they did was they transcribed the videos. They removed all cultural references. So like anything that referred to pop culture or things that would obviously identify that video as being from Japan or Germany. Question?
Actually, going back a little bit, if you
Yeah.
think about it, I mean, like 100, 150 years ago, you could have gone up to someone and said, I can't read, and they wouldn't have looked at you funny, because a lot of people couldn't read.
That was 100 years ago.
Yeah, I know, but it's just a trend. That there was
It
a
is.
big push to increase literacy, and it didn't come with, mathematical equivalent.
Mm-hmm. This is unfortunate because technology is sort of the wave of now, right? So we'd like to be there. But absolutely, you're right. Okay, so what happened? They took away all cultural identifiers from these videos and then rated the videos on quality of instruction. So that, okay? So you've got high instruction, medium, and low instruction. Oh, why'd you go so fast? Darn, I was going to make that suspenseful. Take a look at this table, you guys. So Germany and Japan, relatively high percentages of high quality instruction. And it's sort of a distribution that you would expect, right? But then you get to the US. 0% high quality instruction. Wow, right? So what does that mean though? What does it mean that US students are regularly getting medium and low quality instruction? What does that mean to you? Yeah.
That we don't really suck at math, and we just have terrible teachers.
Oh, tragic. Okay. All right. Well, what is so? Okay. But what does that look like? What does it mean? What does low quality instruction look like? Yes.
Well, my question is, like, what does it mean by quality? Like, are they teaching wrong information?
It's not necessarily wrong information. More like, so quality of instruction, there's this idea of coherence, significance of ideas. So creating connections between the material, teaching for concepts, as opposed, oh, now I'm giving away all the answers. Somebody jump in. Yes.
Well, I know, like, even last semester when I took pre-calculus, I took pre-calc in high school,
Mm-hmm.
and it was definitely a lot easier for me in college than it was in pre-calc because my instructor actually went into detail as far as to why we're doing what we're doing, and a lot of my classmates didn't like that.
Mm-hmm.
They don't like math. And so, to
Which is
me, it's
okay.
like some of the instructors are afraid to like go into depth because students just kind of like give up and don't want to do it.
Okay.
I just want them handed to them. So, I mean, I think it's both parts.
Both parties. Do you have something to say?
Yeah, I was gonna say, I think low quality instructions where you sit in the room and they say do this step and this step and this step and follow after you. And high quality is where they intuitively understand why you do each step.
Okay. Anyone want to add to that? Sir?
Actually, I was just wondering how you could, strip enough national identifiers out to make something from Japan represent something from America.
It was not an easy task. There's a whole book written about it. I will be happy to reference for you after class because I don't have it off the top of my head. But it's an interesting read. Yes.
I think where I was going to go off was something of what you said, but I can't remember.
Okay. You got something?
Yeah, I had two things. One, who did the study? Who rated this as high, medium, and low? Because that's kind of an opinion.
So it was, let's see, Tim's was they had an international panel of educators, but I don't remember.
I would say that in terms of high quality education, that like standardizing your education, so that basically saying that a one size fits all education for everybody in the country might be a negative thing, whereas somebody or a country who could tailor make things to maybe a classroom, maybe a student, if at all possible, would do better than, and which is evident in the
Right.
By the fact that it's there, so.
True. So these definitely, though, were not looking at a broader perspective, right? These were very much localized on, okay, so we've recorded these videos, 8th grade classrooms. This is what we saw. Yes.
The quality of more to do with the interaction between the teachers and the student, how the teacher is presenting the material.
Mm-hmm.
So I think that maybe one of the reasons maybe what progresses so well is maybe the teacher stands up and lectures, kind of presents the literature on the board, the students hand in classwork or some sort of homework, and that's kind of it. Whereas maybe in other countries, Germany and Japan, it's very interactive, there's a lot of discussion going on about the concepts and theories, it's based a lot on the students trying to comprehend and explain it back to the teacher, and that's how you develop kind of a high education in students and teachers.
Absolutely. So I think between that comment and the other one about procedural knowledge, we've really hit the nail on the head, right? So definitely, for better or for worse, the standard U.S. mathematics classroom looks like, here's how you do something. Please repeat this process for me 15 times. It's not what you're going to get here, okay? It's not going to be like that in this classroom. Yes, sir.
One thing I noticed, like, with this is that when I was first learning, like, higher level math, like 6th grade,
Mm-hmm.
it was the connecting, basically what we're doing now. But then when I moved on to high school, they went away from that and just did the whole follow here's that. All this just, and I thought it would be completely different, like, as you go higher up, so.
Yeah.
Like, they went away from it.
That was my experience as well. I was really good at that, right? It worked for me. And like I said, it wasn't until just a little while ago that I realized that there was this whole bigger picture that I'd been missing out on. So calculus, just a bunch of complicated procedures, right? How many of you have seen calculus before? Oh, okay. So this will be really cool because you're going to see it hopefully in a different way. What's the point of learning calculus when you have the web, right? So if you've taken calculus before, chances are you have done lots of things called derivatives and integrals and whatnot. And probably at some point you've seen this website, Wolfram Alpha, and you realize that it does everything for you way faster and more accurately than you could ever do. So what's the point of training you guys to be machines when we already have the machines? So this is a sample calculus, a very typical calculus problem that you could see. It asks you to compute an integral. If you don't know what that means yet, that's fine. You shouldn't, but you know, here's a website that will not only compute an answer for you, it'll also give you a picture and show you a whole bunch of other things. Yay, right? We have the technology. We are not here to train you to be machines. That's pointless. We already have them. Also, Graphing Calculator, the program that we're going to end up using, it will do all of this for you too, in a blink of an eye, right? This is a really complex function to take a derivative of, and we could spend an entire week, maybe two, discussing the rules to make this computation happen. But as you saw, I just clicked a button and it instantly appeared. We have the technology. So if we have the technology, what's your job? What are you here to do? Right? Historically, people needed to be fast at doing these things because we didn't have the technology. But times have changed. So what we need for you guys to do is to understand what functions are important, what procedures will get to a solution to solve a problem that you are presented with, right? Think of it as, you know, if we're working in a restaurant, you guys need to be the managers. You need to be able to coordinate what the waiters are doing, what the bartenders are doing, what the maitre d' is doing, and coordinate all of that from a bigger bird's eye view, okay? Yes. So you need to understand what you're doing and be able to explain why you're doing it. Okay, so if you, some of you have already started to do this reflection, I've heard. So if you reflect honestly to yourself, when you've worked your previous experiences in pre-calculus, maybe even calculus. When you worked with symbols and performed computations, to what extent did you understand what it all represented? Let's take a moment to think about that. Because a lot of you have said that you've taken calculus before. How much of that had meaning for you? So this class, like I've been saying, is supposed to be different, okay? We're trying to develop an expert knowledge of calculus. We want you to be able to figure things out and not just remember what procedure to do next, okay? So if I present something that seems familiar, pretend like it's not, right? A ton of you just raised your hand saying that you've seen some calculus before. So you're gonna see things that are gonna trigger memories like, oh wait, I've seen this, I've done this. Try your hardest to push that down and try to take on the meanings and ways of thinking that I'm trying to promote in this class, okay? Because that's what's gonna serve you now and in the future. So things like this, we've seen this before, and we're gonna talk about this. And when we talk about it, try to stay present in our conversation, okay? All right, so the moral of the story, good math instruction in the US is not good by international standards. So we want to change that, and we're going to start in this class. Okay? So this class is not about memorization, replicating examples, doing without thinking, or guessing what I want to hear. Right? It is about understanding ideas, developing insight into the world of quantities and relationships among them, seeing ideas as coming in groups, right? We want cohesion to the ideas that we're talking about. And to see the course as an endeavor for coherence. With the driving force behind it all being this idea called the fundamental theorem of calculus, okay? That's gonna be present in 80% of the things that we do. Which if you've taken calculus before, you may or may not have seen it. I taught calculus 3 times at the University of Georgia, and I never once mentioned the fundamental theorem of calculus. It wasn't supposed to be in the curriculum. That's bad, right? So, okay. Like I said, I'm really nervous, but really excited to be here because this is my opportunity to do something different. Just like it's your opportunity to get something different. So I hope you'll join me on this fun adventure. Okay. So when posed with a question or a problem, expect to have to rely on your own understanding to solve, okay, rather than some example that you've seen before. Try to bring together ideas that we've learned, transfer your knowledge to new situations, and write coherent explanations. Right? Because that's the way that you're going to make all of these connections, is by developing the ideas, creating coherence in your mind, and being able to communicate it to others. Yeah, and probably don't expect to get answers from me. I will be happy to ask you lots of questions and guide you, right? But I try really hard never to just be like, here's the answer, which will often be what tutors will try to do for you. If you go to anybody other than myself, Marissa Bell, or Mark on campus, they'll probably look at your work and be like, oh, let me figure that out. That's not very helpful, right? So you don't want to go to those people. You want to come to us as much as possible. Not to mention a lot of the ideas that we're learning are the ideas of calculus, but they look a little different than what your friends are going to be doing in their calculus classes. So don't be surprised if you take your stuff to a tutor and they say, I don't know what you're doing, okay? Don't be surprised if that happens. Okay, now, as I said, this is my first time having the pleasure of teaching this class in this format. I've taught traditional calculus. I was very dissatisfied with it. So I'm really excited to have the opportunity to do it this way. Mark was kind enough to lend me some student insights from his experiences teaching this class. So student 1 posted on Rate My Professor this comment. He's honestly a terrible teacher. Nice person, but tries to teach the why and forgets about the how. It really kills your grade. So, what do you think this student expected to get out of their calculus class? What do you think their expectations were coming into the class? Yes? Regurgitation method. Yeah, probably, right? That's exactly what I thought too. Right? Most likely this student thought that a good teacher is one that demonstrates and explains complicated procedures really well and assigns grades based on the ability to mimic them. Okay? Here's another student that Mark had that sent him an email. For the first 4 weeks of class, I left every day feeling that my brain had been mauled into abstract obscurity. Now I was actually helping my friend from another college with her Calc 1 homework. She was amazed at how much I knew. And even though all of our language was different, derivatives, etc., I was able to teach her about why each piece works and what it is there for. I've also been helping people at my table from classes as well with homework. It's so satisfying to have these daily aha moments finally. Okay? If you don't have to send me this email, although it's always nice to hear these things, but if you have this type of experience, I have achieved all I need to achieve in life. It's a beautiful thing. Yes? Mm-hmm.
What if, I mean, both aspects seem so valuable. Why would one be more than the other? The regurgitation is very helpful, so is the understanding of
Mm-hmm.
it. Why is the understanding, what is the forefront versus what you call the regurgitation?
Mm-hmm.
Regurgitation, for somebody who is just trying to do the understanding, it doesn't understand the regurgitation part. How is it going to work together? I don't,
Well, so the idea is that if you understand the concepts, I don't want you to think that we're not going to have you solve problems, right? You will be solving problems and you will be attacking new ideas. The regurgitation that people come to expect from a calculus class, though, is something along the lines of, here's a product rule, here's a quotient rule, here's how you take a bunch of derivatives, now do that 20 times. That's not valuable instruction, because at the end of the day, what are you going to leave calculus thinking calculus is about if we do that kind of instruction? Well, calculus just became a bunch of procedures and pushing symbols around, and that's not what we want, right? We want you to understand this idea of accumulation and rate of change and the big picture ideas. There are ample opportunities for practice. You will take derivatives. You will still have that skill leaving this class. So you will be prepared to do the computations that come with Calc 2 and Calc 3. I don't want you to walk away today worrying that you're not going to be prepared for that. You will be prepared for that, okay? But you will have the added bonus of seeing the big picture, okay, when you leave this course. Yes?
I took actually a class last semester for
Mm-hmm.
Calc,
Mm-hmm.
and I'll be honest, the first 4 weeks I was struggling really bad.
Yeah.
But, and I had already taken pre-calculus before,
Mm-hmm.
and I'm thinking, why is it so difficult? I
Right.
just regurgitate this, and the same thing you're talking about.
Mm-hmm.
But now I see the difference.
Mm-hmm.
I can actually feel confident that 2 years from now, I can retake that final exam, and I can pass it with an A, just like I did last semester, and without ever having to remember or regurgitate any of it.
Yeah.
I actually know why I'm doing it, and that's actually a lot more helpful than just regurgitating everything.
That's awesome. But as you said, the first few weeks were a little bit of a struggle, right? Because it's an adaptation to something new. Yes, sir.
I actually took a math course in Ireland that included a calculus component. And they were in the middle of a big change in the way they teach math over there, but the calculus component was still from the previous curriculum. It was the only bit that hadn't been changed over to the new curriculum yet. The old curriculum was all about this is how you answer the questions that will be on the exam.
Yeah.
And that was the part, and the reason I'm taking calculus again, even though I've already taken a calc course essentially, is that because that was the part that was still just like that, I barely understand any of it, even though I took the whole course.
Right. And you probably did well in the course, too.
Yeah.
Yeah. So the point of sharing this, though, is to highlight the first 4 weeks, right? There will be an adjustment period. We'll try to minimize that as much as possible, but do expect it, right? Because a lot of times dissatisfaction, frustration, these things come out of having different expectations. So I'm expecting one thing, you're expecting another, and if it stays like this, we're gonna have a really hard time communicating, right? So the point in me taking all of today to talk about how this is a different class is to try to get your brain amped up to be like, oh, this is a different class, okay? So from last semester, there were 46 students who completed this version of calculus, and this was the grade distribution. This is a typical calculus grade distribution. So as much as I am preaching, this class is different, and you're going to actually come out of it knowing a lot more and what have you. I also want you to realize you are still getting the same information. It is still the same level of difficulty, maybe a little bit more, but at the end of the day, the success rates are standard to what every calculus class that's taught at this university looks like, okay? So there we go, meaningful learning. It's gonna require work, patience, and perseverance. All right, so there are 2 fundamental problems that calculus addresses. The first is you know how much of something there is, and you want to know how fast it's changing. And then the other problem is the reverse. You know how fast something is changing, and you want to know how much of it there is. That's it. 2 sides of one coin. Those are the problems we address in calculus. So if anybody asks you what calculus is, here it is. That's it. For those of you who have seen these words before, the first refers to differential calculus and the second refers to integral calculus. Okay? But again, the idea is this. Quantities change, right? And as they change, they accumulate. That gives you one direction. The other direction is that everything accumulates bit by bit. Okay, and so we can look at the rates of change of these accumulations. And this cycle is 2 sides of one coin, 2 sides of the same idea. And that idea is what we call the fundamental theorem of calculus. This is what it's all about. I have just told you calculus. Yes, okay? All right. Now, there's something important to note that's going to be a little different, which is that unlike all of your friends who are taking calculus, we are not starting with ideas of limits and continuity and things of that nature. We are instead going to focus on the most important fundamental element of calculus, which is the notion of quantity, okay? So let's talk about what quantities are really fast. And we're going to do that via example, okay? So let's pretend that you have an instruction on a drink mix. Oh, this is so great. Sorry, personal thought just happened. The man I intend to marry is a food scientist, and this is what he does for a living. He makes drink mix, anyways. Okay, I just made that connection. So, I know, focus, thank you. Instructions on a drink mix container say 16 tablespoons of powder should be mixed with 60 ounces of water. Fairly standard problem, right? So, let's think about the following problem. How can we model the quantities with an illustration? So you might think, oh, I could like draw a picture of a glass of water and tablespoons. You could definitely do that. But if we were going for a general representation, something that can apply to multiple scenarios, I'm going to suggest that we use these bars. That's weird. Okay, so now talk to a neighbor and figure out how we might do that. Oh, talk to a neighbor? Do you guys like each other yet? Time to like each other. So any ideas? What could I do with these bars? Yeah.
Well, you can see how much the smaller bar fits in the larger bar, and figure out the quantities after.
How much of the smaller bar fits in the larger bar? Well, what do the bars represent? Do you have an idea? No? Yeah?
Well, not exactly how much of this block is larger because it's not proportionate, but the larger bar represents the 60 ounces of water, while the smaller represents the 16 tablespoons of powder.
All right, let's see if I can do this. So this is going to be, oh, where is it? Number, of, oh, it doesn't like me. Hold on. Ounces of water. My handwriting will get better. And then this bar could be what? Number of tablespoons. Is it TBSP? Tablespoons of powder, right? So on this bar, how much is that quantity? 60. And on this one? 16. Does that make sense? Okay. Yeah, ounces and tablespoons. Okay, so how many ounces of water should be mixed with 1 tablespoon of mix to achieve the right taste? How could we use this diagram to answer that question? I see a hand.
Multiply by a ratio relationship, so if you have 16 ounces for every 60, then you could write that 16 in.
So you're thinking 16 over 60.
I would go breaking 16 divided by 16, that's going to give you 1, and then 60 divided by 16 is going to give you the number of ounces of water for that 1 tablespoon of powder.
Sorry, I'm not following. Say it again.
So 1/16 of the 60 ounces.
1/16 of 60. Okay. How could we visualize that using the bars? So 1/16 of the 16. And then 1/16 of the 60 as well, right? So these are the corresponding parts. Okay? Does that make sense? There we go. Same setup. Now how would you approach this? Use the same bars to illustrate how much powder would be required for 200 ounces of water. The larger bar is going to be 200. Okay. 200. Oh. So you want 200 ounces here. Whoa. Okay. And then what? Well, so if the top bar is 200 ounces, what does the bottom bar represent? How many tablespoons, right? The bottom bar is now the answer to the question. Well, okay, so I don't know what the answer is, which means there has to be some intermediate stuff. Yes, sir. So you're saying, hey, I could think about how many groups of 60, right? So there's 3, and then this, if all of these are 60, right? 60, 60, 60. How much is left over here? 20, right? Which is how much of 60? A third of 60, right? So if I come down here, corresponding to this 60, right? There's going to be 16 tablespoons there, and I can do it again, right? Another 16 there. Whoop! Oh, that was crazy. I don't know what just happened. Oh, sad. Yay, technology. Okay, and then 16 there. And then how much is going to be in this little bit? A third of 16. So then the total amount is going to be, okay, 3 1/3 times 16. Oh, my handwriting better get better. Okay. And that's tablespoons. Okay, so this activity is to get you started on homework for Wednesday. Is that weird? I think it's a little weird. It's not limits. It makes me so happy. Okay, so you know what to do for Wednesday. You're going to get on Blackboard. You're going to download the syllabus. You're going to read it. You're going to hopefully have instructions to install Graphing Calculator on your computer. And you're going to download the homework from the assignments. And you're going to do pages 1 through 5. You will be turning it in on Wednesday. Yes. Yes.
Are we just working on this and turn this in, or do you want a complete separate write-up?
Mm-hmm.